Hi class, this is Hosung So, Kinesiology 370. We will continue to work on t-test. Before I move on to SPSS, I need to correct degrees of freedom for dependent t-test right here. So if you have two groups and if you want to compare their mean difference, that will be independent t-test. Independent t-test, and degrees of freedom will be n1 plus n2 minus 2. However, I made a mistake. Degrees of freedom for dependent variables such as pre-test and post-test, you need to have paired scores. For example, this is a pre-test and post-test, and Chris, and Tom, and so, and this stands for number of paired scores. So we have three paired scores. So n equals 3. Okay, sorry, that was my mistake. So we have n equal 3. So we have 3 paired scores. So degrees of freedom for dependent t-test is 3 minus 1, because they are the same group. Here we have two different groups. So 3 minus 1 equal 2. I just want to correct degrees of freedom for dependent t-test. Okay, so please write down how to calculate degrees of freedom for dependent and independent t-test. Let me close this down. Okay, let's move on to the table in the middle of your handout that we couldn't finish. I hope you can see in the middle right here. We did the first questions, right? We did the first question, and then we still need to the bottom one. I will send you this copy with my hand writings so you can take a look at it. But I really want to talk about how to use SPSS to calculate t-scores, t-values for t-test. Okay, so as you can see here, I already prepared SPSS. So once you open SPSS, you can input all the numbers. So you can see 20, 18, 17, 19, 20, 16, 18, 19, 16, 18, 19, 8 cases for varsity. So this is I need to talk about. So now you have 1 and 2. So SPSS will follow your directions. You are the commander to manipulate SPSS. So now we have a new concept for SPSS, which is dummy code. Okay, dummy code. Right here. So I will write down dummy codes. Okay, so in this case I put 1 for varsity, and I put 2 for sub-varsities. Sub-varsity, right? So same thing, if you have male and if you have a female, I'm gonna put 1 for male, 2 for female, or you can change whatever the two numbers. It could be 3 and 4. Any dummy code that you can identify later in your data analysis, that is totally fine. But the most common dummy code for t-test is 1 and 2, and you will see why you better use 1 and 2. A lot of people use 0 and 1, but I don't have any preference, but 1 in this case is for varsity and 2 is for sub-varsity. So you can see how many varsity players you need to count. Dummy code 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 data point for a varsity, and I have 1, 2, 3, 4, 5, 6, 7, 8 for sub-varsity. So here I just put the score. So now you have two teams, two separate teams. One team is called varsity, and another team is called sub-varsity. So I measured their score. Could be successful serves, invaluable, or maybe the scores they make at the game for basketball. Doesn't matter. Okay, so I just collected numbers as a score right there. So let me explain one more time. If you want to do independent t-test, you need to use dummy codes. Since you have two independent groups, any two numbers can be used for dummy codes. In this case, I use 1 for varsity groups and 2 for sub-varsity. Okay, so now I put all the numbers right there. All the numbers. Okay. So I'm transferring this table in the middle section, the table, to the SPSS. If you look at the t-test for two independent groups, you don't see any means, standard deviation, and means for the second group and standard deviation for the second group. So that means you need to use software, either Excel or SPSS. So in this class, I'm using SPSS to demonstrate how to use SPSS for any data analysis, in this case t-test. We have two groups. The first group 1, second group 2, and computer will identify what this column means, right? So you put 1 and 2. Next, which is very important, to analyze t-scores that we practiced during Zoom class, you can just go to analyze, click analyze. If you see compare means, you will see different types of analysis, and this is what I want to demonstrate. Independent samples t-test. So now you have two independent groups or two independent samples, right? So in this case, varsity and sub-varsity, and you are trying to compare their mean differences using t-tests. So this is the correct t-test in this case, since you have two independent groups, varsity and sub-varsity. Later, I will talk about paired samples t-test. That means you have two groups samples, but these two groups are related. They are paired. That's why I corrected the degrees of freedom for paired samples t-test, which is also known as dependent t-test. So let's go back to this case. We have two groups, and we have scores for each individual in each group, identified by dummy codes 1 and 2. So let's go to compare means and click independent sample test. So let me just move for you. So now you have a different variables, 1, 2, 3, unknown, pre, post, and I added a post number 2 later. So what you are interested right now is you are trying to compare groups, right? So group should be here, group here. And now you cannot really move on to next options. You need to define how you defined your group. So click here. Let me do it again. So now, same as regression, you need to move variables under appropriate options. So now we are on t-test and between groups, right? You need to define. How did you define the first group 1? You defined as 1. The 1 right here. Group 2 and 2. I put the values already to move on faster. So group 1, varsity, you put 1 using the dummy code, and you put 2 for the second group. So this is very, very important. Okay, so you gotta practice a few times. Continue. And what are you interested in by groups? You are interested in their scores. There is any difference between two groups? Any difference on the score between group A and group B? This is a t-test command. Okay, so now you are ready to run the t-test without any hand calculation. Click OK. So step number 1, if you look at our handout, step number 1 is standard error of the mean, which is SEM. So SPSS will give you SEM right there, 0.498. So if you use 2 decimals with a round up, this value by hand calculation will be 0.50, but I'll just leave it as it is, right? So this is the standard error of the mean for the first group. 0.567 is the standard error of the mean for the second group, right? So that is the step number 1 if you look at our course handout. Step number 2 is standard error of distance. Standard error of the distance. And that one you can find out right here, 0.754. And you can see 2 rows right here. The top part is called equal variances assumed. That means your 2 groups are assumed to have same variance. Same variance. They are assumed to be from the population. On the bottom, you can see equal variances not assumed. Then you need to read the bottom results. Bottom results. However, how do you decide which one you need to go? And that means right here, if this significance level is greater than 0.05, in this case 76, right? So this is way bigger than what we usually set at 0.05. That means they are not violating any equal variances. So you just read the top part. If this one is a 0.01, then you need to read bottom. But typically you will see this significance level error rate is greater than 0.05. So I would recommend you to read the top part in this class. So standard error of distance is right here. So you don't need to calculate step 1. No, step 1, mean standard deviation for standard error of the mean. And step number 2, standard error of distance. And t-score is automatically calculated for you. The t-score is 5.136. Remember, 5.136. And degrees of freedom is N1, right? The first group's N plus the second group's N, 16 minus 2 equals 14. 14. And if this t value is significant, then you need to read t-table. T-table. So if you look at t-table for the degrees of freedom of 14, you will see, let me see, where is it? So right here, when df is 14, df is 14 at 95 confidence level, your t-value should be equal or greater than 2.145. What about 0.01 level? Your t-value should be equal or greater than 2.977. What about 0.001? Your t-score that you just calculated should be equal or greater than 4.140 when the df is 14. So our df with the first example is 14, right? 14. And let's take a look at our t-value. Our t-value is 5.136, which is way bigger than right here, 2.179. This t-value is greater, way bigger than what is recommended to be statistically significant in the mean difference. So our t-value is way bigger than what is recommended. What about the 0.01 level? 3.055. 5.136 is still way bigger than what is recommended right here, right? What about 0.001 level? Oops. Right here. 4.14. If they are really different in the means, t-value should be equal or greater than 4.14 at 0.001 level with the df of 14. However, our value is way bigger than what is recommended. Okay, so that is the independent t-test outcomes if you use SPSS. Then next, step 7 and 8, and now you need to report your t-test outcomes. T-test outcomes. So let me just put right here. So you just finished a t-test. So all you need to report for the independent t-test is t parenthesis and degrees of freedom 14 equals, it's not really working. Oops. Right here, and let me put it here. A little bit big. 14. 14. Sorry. 14 equals, what we found out is oh no. Fourteenths equal 5.14. It's not really working right now. I don't know what is happening. Okay. 14. 14. Oh no. Okay, I will send you the T score. So, or I'll just write down right there. So you need to write down T parenthesis 14 parenthesis equals 5.14 comma, and p-value that we found out is significant. So probability that you make an error to report with 95% of your confidence was you can get it from here. Significance level with two tails 0.000. But this one means there's no errors, right? But in statistics, if you see 3 zeros, that means you need to report p-value is less than 0.001 because there are 3 different levels of significance, right? 0.05, 0.01, 0.001. So you can just put p equals 0.000 or p-value is less than 0.001. Okay, so that is how you report. This is how you report right there. Okay, so that is how you use SPSS for independent t-test. However, if you look at the second column in the table, you can see pre and post. Don't pay attention here, post 2, that I just put as an example to show you which one is significant and which one is not really significant. So if you look at the second table, dependent t-test, you have 8 people right there. 1, 2, 3, 4, 5, 6, 7, 8. 8 people could be patients or 8 members took the pre-test and they took the post-test as well. So in this case, again, degree of freedom will be how many numbers of paired scores. So I see 1 pair, second, third, 4, 5, 6, 7, 8. So df equal, let me just put the right there, df equal 8 paired number minus, for dependent t-test, 1 equal 7. Okay, that's something I really want to change from your note. Okay, don't get confused. That was my fault. If you have a dependent t-test, degree of freedom will be n minus 1. Here n means how many paired scores you have. So let me just make it bigger right there. So now you need to use t-test again to compare mean difference between pre and post. So now here pre can be first group, post can be the second group, right? So we have 2 groups. However, the only difference between the first case and the second case is these are unrelated. They are absolutely different people, different groups. Here they are related, right? They are related, mean between pre and post. So you gotta use dependent t-test. So let's get started. For dependent t-test, go to analyze, go to compare means, and now you gotta choose paired sample t-test. So I already moved. So once you click that option, you will see the new pop-up window, right? So now you need to compare paired scores. So the first variable that you want to measure is pre-test. And second variable is post-test, right? So that is your raw data from the table. So now you are ready. Just click OK, and you will see very similar results, outcomes that you did with the first case. So now we have paired sample t-test right there. So pre-test, 8 people took the pre-test and 8 people took the post-test. The mean for the pre is 17.50 and 20 minus 88. So now you can see standard error of the means and standard error of the mean here. And let me see. Right there, but you don't see standard error of the distance, okay? Because they care about how much they changed between pre and post. Okay, so that is the reason that you cannot use the formula that I gave it to you, steps 1 to 8. There is another formula, but that I don't want you to calculate t-scores for paired sample t-test, dependent t-test by hand. Okay, so this is how you use SPSS to calculate t-score for dependent t-test. All you have to read is right there. Degrees of freedom, we had 8 paired scores. 8 minus 1 equals 7 right there. The next, is there any difference, statistical difference between pre and post? Do you really think so? Are you really confident to say there is a mean difference between pre and post? Then you need to read significant, right? That is, you're not going to make any mistake, even 1 out of 1,000. You're not going to make any mistake to confidently report that yes, there was a statistically significant mean difference between pre and post. That's what this really means. So same as independent t-test, let's work on how to report this. Make it down a little smaller. Oops. Right here. All you have to do is T parenthesis and degrees of freedom. We got the 7, right? 7. We got the 7. So I'm going to put parenthesis 7 equals, we got the t-test of t-value of -9. Let me just close this one. I don't know what is happening with this node, right? So I have 2 screens right here. This is the SPSS output and this is my node. Let me just make it smaller. So right here, again, I can't really write. I don't know what is happening. Another frustration going on here. Okay, got it. So based on the SPSS output, T parenthesis degrees of freedom 7, and we found, oh no, 7. I don't know what is going on right there. Right here, okay, 7. So this is how you report dependent t-test. T parenthesis degrees of freedom 7 equal, you can see t value is negative 9.00, and this t value is statistically significant at 001 level. Okay, that is the step number 7. Okay, so let's make sure what is the recommended t value if you have degree of freedom at 7. Let's take a look at t table. If you have a t, well, you can use this table for pre, post, dependent, independent t-test. It doesn't matter. T-test is only t-test. Okay, so we have a degrees of freedom 7 right here. And when you have df7 at 0.05 level, that means you are 95% confident to report. There is a mean difference. Recommended value is 2.365. Our value is 9. So 9 is even way bigger than 0.001 level, right? So our value is way bigger, right? So don't worry about negative and minus and plus sign. So our value is way bigger than 5.401 at 0.001. Okay, so on the SPSS it says 0.000, but there is some type of, well, there are some types of errors that you cannot really see with the 3 decimals. It doesn't, it's not going to be 0.000, could be 0.00023, who knows, right? So let's use one of 3 common significance level here. Okay. Right here as well. So now you have seen 2 significant cases under significance. Let's take a look at the last example. So now you want to compare mean difference between pre and post. Number 2. So don't worry about this one. So now you don't have post 1. So now you have a new data right there. This one you don't see it on your handout. I just created to show you insignificant case. Go to compare means and they are paired, right? So same thing, but now you have the second group, post 2, right? So now you're comparing pre and post 2, not post 1. So now compare, and now you have a new outcomes right there. Pre and post 2 mean and standard deviation. And you see here, this is a region that I want to open with a new sample. Significant level 0.08. This means you have 8 errors out of 100, right? So 8 times of possible errors, right? If you don't look at this one, you can really say, well, in terms of mean, post 2 is way better. So I'm going to conclude that there is a mean difference between pre and post number 2. However, are they really different? Are they really different in terms of groups mean difference? Groups mean difference. And their difference is only here, negative 0.750. Very minimum difference, right? So you can conventionally say, well, they don't look like really different. They look alike. However, you want to make sure if they are statistically different or not. Then you need to read significance level. Yes, well, they are different, but statistically they are not really different. because the analysis that you did might have more than 8 errors. Okay, so that is the paired sample test, t-test, with insignificant case example. Okay, I think the video is getting longer. It takes a long time to upload YouTube, but I hope this video will help you prepare quiz and test and exams. Okay, I'm gonna send my handout with all the answers, right? The first page that we couldn't finish. And I hope you will watch this video, and also I recommended you to watch 4 videos, 2 videos from dependent t-test and 2 videos for independent t-test, and they look very similar with what I've been presenting to you. Okay, so I hope you will get this concept, and if you understood this afternoon's lecture and this SPSS, you will be totally fine for the rest of exams, assignment, and pop quiz. Okay, thank you so much and have a wonderful weekend. Okay, I'm gonna stop the video, and again, sorry for all the technical problems. Okay, but at least you get some